to the next talk by Samuel Senanu from Sintef, who will talk about developing a value chain for high-strength magnets based on rare earth minerals from Europe. Yes. The floor is yours.
Okay, thank you very much, and it's so good to see so many faces today too. And as I said, my name is Samuel Senanu. I'm coming from Norway, Sintef. And the title of my presentation today is Developing a Value Chain for High-Strength Magnets Based on Rare Earth Minerals from Europe. And this is a presentation that we put together by myself and the project coordinator that I'm going to talk about. And I think this is going to be a very good and natural continuation of what Salih just presented. Now, this is going to be the outline of my presentation today. First, talk about why do we really need these rare earth magnets or permanent magnets, the overview of some of these rare earth magnets, the motivation for the reason why we need these magnets, and then also looking at the rare earth elements value chain in Europe. And then I'll go to talk about this Supremo project that we have, give you a little bit about project overview, the concepts and objectives and the work plans and tasks, and also the outcome of the for the project. So Supremo, by the time I'll finish with this presentation, you all know what Supremo stands for. So why do we need rare earth permanent magnets? Why are they very important? And I think we've seen a lot of presentations already. We need these very, very strong permanent magnets in the wind turbines, electrical cars, and all these things that needs very, very high electromagnet forces to be able to operate. And you need these permanent magnets. Very, very strong permanent magnets are very, very important for so many reasons. And what are these magnets? I want to talk about magnets. What are the overview of magnets that we have? We have different kinds of magnets. We have the ferrite magnets that most of us probably know. We also have aluminum, nickel, cobalt magnets. And then we also have these samarium cobalt magnets, which are also very strong magnets, but very, very expensive. And then during the 80s, Masato, Sagawa, and then General Motors were able to come up with this neodymium ferrite boron permanent magnets, which actually happens to be the strongest permanent magnets on Earth. There is no permanent magnet that is as strong as these permanent magnets, and that is what we are going to talk about. So we need these permanent magnets that have this neodymium ferrite boron. So when you're talking about neodymium, praseodymium, terbium, and then dysprosium, these are the rare earth elements that we are talking about. These are the ones that you really need to be able to produce the permanent magnets that you need. You normally have this neodymium, praseodymium in your permanent magnets, and then you also have to add this terbium and then praseodymium because of their high temperature strength resistance. Because when you have a permanent magnet and then the temperature begins to increase, they tend to lose their magnetic properties at very high temperatures. But then if you have this dysprosium and then terbium in there, then it's actually able to be resistant to high temperatures. So you need these rare earth elements to be able to produce these permanent magnets. And even as we're talking about the green transition in Europe, then of course permanent magnets becomes a very, very important. And these are some of the motivations just to show the projections that have actually been done when it comes to permanent magnets. Is one of the materials that is going to keep on shooting, and that's because we all want to decarbonize our industries. We want to decarbonize the society that we live in. Then we need more of these wind turbines. We need more electrical cars. We need all these technologies that are dependent on these permanent magnets. So as you can see some of the values just to show us the projections from 2030 to 2050 of these rare earth elements that we need. And when it comes to having a value chain in Europe, it's a very, very critical thing, and it's all good that the European Union has seen the criticality of having rare earth element value chains in Europe. Because currently, when it comes to the rare earth elements market, I think China dominates fully. In some cases, it's 100% dominance by China. And so if you want to have and it becomes then a geopolitical issue that when it comes to security, you need to be able to have your own value chain. So the fact that the AU is looking at establishing rare earth elements value chain in Europe is actually it's a security issue if you want to look at it in that way. It's a very, very important thing that we are talking about here. And I think we've all seen the supply risk and then economic of all these different materials. And as you can see, the high rare earth elements, as you can see over there, this pointer doesn't work, but as you can see, the high rare earth elements and then the low rare earth elements are all very, very critical elements when you come to what the AU has described as critical. And I think I don't need to spend so much time here, but from the presentations that we received yesterday, we saw that when it comes to this northern part of Europe, we're actually sitting on a lot of these minerals that contain the rare elements that we need. So if we're able to, if we want to establish the value chain, we have the potential, we have the possibility to do it because we have very, very large deposits. And I'm coming from a country, Norway, which actually has been seen as the one that has the largest deposit of these rare elements in the Fensfeld in Norway. And you can see the values here. These are huge, huge amounts of rare earth elements, oxides that can actually be used or can be used in Europe. And this is actually possible to basically supply all the need that Europe needs. So all that we have to do is just to establish a value chain that will be able to use these materials that we already have present in Europe. And so having this as a background, then it's very important that we actually establish a value chain here in Europe. And that's where this project that we are leading comes in. And as I said, by the time I finish my presentation, I think we are all going to be able to know what Supremo stands for. We're going to have a Kahoot maybe so that we'll find out whether I still remember. So Supremo stands for Sustainable European Rare Earth Elements Production Value Chain from Primary Ores. So we are looking at producing this permanent magnets, rare earth permanent magnets from the primary ores. We are looking at the whole value chain. And as I said, it's an European Union project. And SINTEF, where I come from, we are the coordinators of this project. And we have 11 partners from 9 countries. As you can see, we have Norway, Netherlands, Sweden, Slovakia, Czech Republic, United Kingdom, Slovenia, Belgium, and France. So we have a lot of these European countries as part of the consortium in developing this value chain. And the budget over here is 7.06 million euros. And of course, the United Kingdom, because they're not part of the EU, they have their own funding that they also come in. That's why the contribution for EU is 6.4, even though the total budget is 7 million euros. And so Supremo, we have a lot of objectives, and this is a project overview. So as you can see, as I said, we have this partners, and all the partners have a role to play in the project. So we have the REE minerals in Norway, and Diamo in Czech Republic. They are going to supply the ores that we need for the project. And then we also need to do the beneficiation that Salia was talking about. You need to do a lot of beneficiation to be able to concentrate to the levels that you want. And that's going to be done by TU Delft in Netherlands, and then TK in Slovakia, and then SINTEF is also going to help with that. And then we're also going to use this hydrometallurgical processing to be able to process the material into the ores. That's what you need, into the oxides. And that is going to be done by Chalmers and Diamo. And then, of course, we also, once we get the oxides, you have to then extract the metal from the oxides. And that's by the electrowinning processes. And that's going to be done by LCM in the United Kingdom, and SINTEF, that is us, is going to help to do the electrowinning process. And once you have the metal, which is the rare earth element or the metal, you have to produce the magnets, permanent magnets from them. And that is going to be done by Magneti Ljubljana in Slovenia. They are going to do that. And then, of course, we have these other parts of the project, dissemination and outreach activities, life cycle assessments, very, very important. Every project or every value chain, you have to consider the life cycle assessment is very, very crucial part of the projects that we're going to do. And then we also have kind of stakeholder engagements, which is going to be led by Prospect Institute. So these are the partners and what they are supposed to do. And what do we want to attain? What is our objectives with the Supremo? What is the aim? And that's what is written over. The first is to establish the first pre-commercial rare earth elements production value chain, and at TRL7. So we want to, by the end of this project, which is going to be, it's a 4-year project, so it's going to be in the ending of 27 or 2028, is actually to be able to establish a value chain at TRL7, and also to utilize, whereby we are utilizing European Union primary resources as a feedstock, and also develop a sustainable, cost-competitive processing. Then also support the rare earth permanent magnet production technologies, because we already have the technologies for permanent magnets, just to give more help to how the processes go on, the electrolysis winning, the permanent magnet production, and also to contribute to a reasonable value chain complying with local and international safety regulations. So it's always very, very important that whatever process or production that you are doing complies with both the local and the international safety regulations that are established. Very, very important. And when it comes to the specific objectives, then of course we want to develop and optimize effective beneficiation technology for the gang removal. We also want to develop and demonstrate advanced flotation processing that is with high-grade rare earth concentrates. Also to optimize sustainable leaching process to efficiently extract the rare earth elements from the complex structure, develop circular and low-cost process for selective recovery of rare earth elements and removal of the radioactive elements, because we all know that these rare earth elements sometimes have these radioactive elements, so it's very important to have a very good process for that. And optimize and develop highly efficient electrowinning of the rare earth elements alloys that you need. That's the neodymium, praseodymium, and dysprosium, terbium, permanent magnets. And then also to demonstrate an environmental, social, and economic sustainability of the Supremo value chain. And of course, to communicate activities. It's very, very important that whatever we are doing, we communicate with the people, because one of the things that we always have to remember is that when we scientists meet, we understand each other, but the person on the street doesn't really know what we are talking about. So it's very, very important that we have this kind of public engagement so that I give them an idea of what we are doing and the importance of this to the whole environment and the globe that we live in. So it's very, very important. So back to the Supremo. So these are the concepts of the Supremo project. So of course, as I said, we are starting from the ore to the permanent magnets. So we have the REE minerals and the ammo. They are going to ensure that we get the ores that we need. And then we have the beneficiation processing. We have optomagnetically induced sorting, and then magnetic density separation, and then we have the fourth flotation. So these are going to be the techniques that are going to be used for the beneficiation. And then we also have the extraction, where we are going to produce the ores, and that is going to be like flexible hydrometallurgical cracking processes. And then you also have the separation, the purification, whereby you have the selective separation of the rare earth testa, and then by solving extractions. And then, of course, you have the highly efficient electrolysis processes. And I think yesterday, one of the things I was saying that we have the ores, but then when it comes to the electrolysis process, maybe that's not, it's only the Chinese that are doing it. That is true, but when it comes to the technology, electrolysis is something that is done strongly in Europe. Norway is the largest producer of aluminum in Europe, and to produce aluminum, you need electrowinning, electrolysis processes. So this is something that we're already doing. So it's just about changing the feedstock from aluminum oxide to rare earth oxides, and it's the same. Electrolysis, you develop the oxide material in a fluoride melt, you pass electricity through it, and then you produce a metal. So this is a technology that we already have, and all we have to do is just to focus on using it on the rare earth elements. So this is something that we can do. And then, of course, after the production of the metal, you go to the permanent magnets, and as you can see, we have the partners that are also going to do that. So this is going to be the good value chain that we are going to do. And then the work packages, as I've already said, these are going to be the work packages. We normally structure our projects into different work packages. You have work package 1, which is going to be the project management. Work package 2 is going to be the supply and the characterization of the feedstock. Work package 3 is going to be the beneficiation, effective sorting, and process optimization for high rare earth concentrates. Work package 4 is going to look at the sustainable extraction and purification of technologies to recover the rare earth oxides from the mineral concentrates. And then work package 5, which is going to be the extraction or the electrowinning or the extraction of the metal from the metal oxides. And then, of course, we also have the work package 6, is going to be the upskilling and validation of the Supremo process. Work packages is going to the environmental and economical sustainability assessment with valorization of reducer matrices. So the environmental part is always very, very important. And of course, the work package 8 is going to focus on the communication, dissemination, and then exploitation. So it's going to be something that's going to be available to everybody to be able to, update themselves on what we are doing in the Supremo project. So when it comes to the different work packages, so work package 1, as I said, is a project management. And the objective of work package 1 is to develop effective and transparent administrative, financial, and legal management to successfully execute a project. So you monitor and ensure that proper health and safety guidelines as well as ethical related affairs. So the project management, as I said, is going to be by all, but then Syntef is going to be the coordinator, so it's going to be the lead for this project. And then also we have the supply and characterization of the feedstock, which is the work package 2. And what you can see there is actually from the fence field. So we see people doing some kind of excavation around this fence field just to get the material. And as Salia was saying, it's very, very important that you characterize the ore that you are going to use. You need to know what you are mining from the floor. You need to know. So characterization is a very, very crucial part of this whole process of the supply. The feedstock, we need to know what we are bringing up from the soil. So that's very important. And of course, we have the supply and characterization of the ores from the different partners. And then the work package 3 then goes to the beneficiation, that's effective sorting and processing optimization for the high rare earth concentrates. So you mine and then you beneficiate just to be able to get, reduce, because whenever you mine, you always have other materials with the mineral that you're interested in. So you have to do some kind of beneficiation just to reduce the impurities or the other things that you're not interested in as much as possible so that you have more of the concentrate. And so the objective here is to optimize the sorting, density separation, and milling operations towards achieving effective gang removal with minimal rare earth losses, and then to develop a beneficiation flow sheet by loop testing operation to achieve about 50 to 70% gang removal targets, and then to optimize the fraud flotation cell to achieve about 35% rare earth concentrate. So it's very important that you get a concentrate that is very, very high in the material that you are interested in. And then, of course, we also have the next, after the beneficiation, they go to the sustainable extraction and purification technologies to recover the rare earth oxides from mineral concentrates. And so the objectives here is to effective liberation of the lanthanides from mineral concentrates and also improve purification of the lanthanides from the leach liquor. And that is going to be done by the partners that is listed over here. We have CTH and Sintef and then TK and Diamo all going to be part of this process. So once you form the oxides, you go from the mineral, from the floor, it goes through the beneficiation, it goes through the extraction and all that, and then produce the ore. So then you can have the neodymium oxide, praseodymium oxide. These oxides, that is what you do after the work package 4. And then you go to the electrowinning. And electrowinning is where now you get the metal, because that's what you're interested in, not the oxide. Then electrowinning is where you use this electrolysis process, actually. So basically, we dissolve the rare earth oxide in the rare earth fluoride. A fluoride melts at a temperature of around 1,040 degrees Celsius, and then you pass electricity through the system, and then, of course, your positive ions are deposited in the cathode to form your metal. And then oxygen, of course, goes to form with the water, and then goes off, and then you get your metal at the cathode. And then that is what you then use to produce a permanent magnet. So this is something that's going to be led by Sintef, and then with the help from LCM, less common metal. So as you can see some pictures of LCM, this is their traditional production. So you have a kind of a bucket, and this is actually the main technology in China. Is produced using this technology. So you have a kind of a bucket system with one electrode configuration, and it produces the metal. And what we suggested, the innovation that we want to come with the Supremo project is to develop a multiple electrode system so that you'll be able to increase the productivity of the process. So that's something that we're going to do. And then, of course, the work package system goes to upscaling and the validation of the Supremo process. So we have to design, adapt, and commission the operation of the flotation and rare earth extraction pilots. So we are going to have a kind of pilot systems and then operate and validate performance of pilot for production of high-quality rare earth oxides, validate the performance of the electrolysis plant, pilot at the production of a rare earth element alloy, and then obtain a strip-casted rare earth magnet alloy to manufacture the neodymium-based permanent magnets, and then, of course, to characterize their performance. So once you produce the permanent magnets using this value chain, you also have to characterize the performance. How does this permanent magnet that have been produced during the Supremo compare with other permanent magnets that are probably produced in China, or the material is sent from China and then produced in Europe? You have to compare and see, does it really compare in terms of the market? It's very, very important that you can be able to do that. And then, of course, you also have the environmental and economical sustainability assessments with valorization of the residual matrices, as I was talking about. So you need to have an effective valorization of the residual matrices throughout the value chain. So you will always have kind of gang materials and all that. You have to find an effective way of using it. So having a kind of closed cycle systems is very, very important. And then also set a goal and scope of the LC and LCCA, targeted environmental and economic analysis demonstrating improved performance of the Supremo, and also to improve the safety of waste disposal using innovative waste management, including reduced cost of waste. And then, of course, the work package 8, as I said, is just a communication, dissemination, and exploitation is always very, very important. And so these are the expected impacts. To establish the pre-commercial earth production, as I already said, increase the recovery rate, at competitive costs, and also circular practices, and also to have a critical raw material target that we need. And I would like to say thank you very much for listening to me. And for those that are interested and want to know more about the Supremo project, this is us. This is the project coordinator who was supposed to be here, but he couldn't be here, and I'm here for him. And then this is also mine. So these are our contacts. And the Supremo project just started this year. So we're working, and of course we are open to have collaboration with, I've spoken to some people in the audience already. We are open to have collaboration and to work together with others that are also interested in establishing a rare earth element value chain in Europe. Thank you very much.
Thank you, Samuel, for this nice presentation on a very interesting project on rare earth elements. It's nice to see something after discussing just the resources, but also about how to process these critical raw materials. Time for a quick question. Yeah, Catherine.
Thank you, Samuel. Really interesting. There's a few of us in this room that were involved in the EU RARE project 10 years ago, which had exactly the same aims as your project, and indeed many of the work packages were very similar. We learned a lot, but we haven't managed to get a European rare earth value chain going. So my questions are, what will you learn from EU RARE, and how do you anticipate being able to have different impacts now, 10 years on?
That's a very good question, and I think that was yesterday one of the questions that was asked to the AU coordinator who was here was, what are the success stories and what do we do with the results that we get? So what we actually aim to get with this project is that there's a kind of a wind shift now. We see that there is this press to actually consider rare earth elements, and Norway with this Fensfeld. Recently, the foreign minister of the US and that of Norway actually signed an agreement that they are going to work together when it comes to this. So things are happening. And so we believe that the value, and there's a time is going to come when this value chain is going to be created. And then the results that we get from this is then going to be used, or we can then help the industry that we've done this before, and we want you to see if you can use this. One of the partners is LCM, who is already producing this rare earth elements alloy. And we are just trying to help them to actually optimize their process through this project, because you're also having this old technology. So you use the technology, the results that we get with them. So we have an idea, we just talk to them, and then they see if they can implement it in their already running process to improve their production. So this is something that we plan to continue with and to share with the industry that we have in Norway.
Okay, a last final question from you.
So we heard from our last talk that mineralogy is key when you're trying to develop one of these types of projects. And obviously, FEN's been known about for a huge amount of time. FEN's done a huge amount of work on FEN. So could you remind us of the mineralogy that you're actually targeting, and what is going to be the target for your flotation and sort of further beneficiation processes?
Okay. Thank you very much for that question. So it's the rare earth elements oxides, and we are looking at neodymium, praseodymium, dysprosium, and terbium. These are our main focus. But then, of course, you have, when you look at the mineralogy of the Fensfeld, they've done, rare minerals have done a lot of characterization of the ores that they've gotten from the Fensfeld. And you see we have, of course, lanthanum there, we have cerium, we have all of these rare earth elements over there. But for the focus of the project is to look at this neodymium, praseodymium, terbium, and then dysprosium. These are our main focus, to look at them over there. But the mineralogy contains most of these rare earth elements that we are interested in.
Okay.
Yes. Oh, carbonatites. It's a carbonatite. In the ores, okay. No, I'm not a geologist, so I think you are. But we have different ores that are in there. But from what I've read is the carbonatites that contains the, I've forgotten the name of the minerals, but we can discuss that one. I have it in a paper over here. Okay. So we have different organs in there. Yeah.
Thank you.
Yes.
Yeah, we have to move on.
Yes.
So
thank you very much.
Yeah. Thanks again. I'll leave the floor to you, Saya.
Okay. Thank you, Jakob.